solving logarithmic and exponential equations. And we're going to talk about the change of base formula and how we can apply that in solving. Okay, we're going to begin with a change of base formula. Log base b of m is equal to log of a common base of m over log of that common base of b. C could be any number you want it to be. It could be a 3, it could be 4, it could be 5, it could be whatever. Typically, the point of doing this was because the old calculators wouldn't do logs of different bases other than 10, so you would rewrite this as log base 10, be a common log, and then you could calculate this on your calculator using this technique. Mrs. Mills and I both agree that even though these calculators will do this the way it's written, we're going to have a question at least that requires you to show that you can use a change of base formula to do it. So, in other words, you're going to have to show us how you would rewrite this using base 10 and then going from there. And so when I rewrite this, I'm going to go base 10. So this is log of what? 8 over log of 3. Some people confuse where the 8 and 3 go. And I didn't write the 10 there, but understand that it's understood to be log base 10. Okay? You don't have to write the 10 in, but it's understood that it's there. We're not just nonchalantly leaving off the base. We're intentionally changing it to base 10. So then you could do this on your calculator, the old calculators. Press 8 log, divide 3 log,
I'm really hoping this is correct.
0.477.
I just kind of made it up as a number.
Now let me redo it and see if she did it right. So I go 8 log divide 3 log equals 1.89.
Don't say I didn't do it.
Try it again.
Probably just here.
Why do you have to put the number before the log?
Because that's the way this calculator works.
Dude, I did the same. Do I have to hit second?
Try it with your calculator, but use base 10. Log 8 divide log 3. 8 log divide 3 log equals.
What did I do last time?
You probably didn't get equals. You probably just gave me log of 3. Okay? So remember it's base 10, so just skip over the base and go log 8 divide log 3 and give me the answer.
I got 1.89.
1 point what?
89.
1.89? Maybe I just didn't read it right. 8 log divide 3 log. Yeah, you just didn't hit equals. Yeah, I have 1.89
Yeah, you
also.
just didn't write it down right, but that's what you said.
Oh, okay, good. Thank you. 1.89.
Yeah.
I said this, but I didn't write it what I said. Okay, good. So senility is hitting me at age 49.
No, you were.
So-
I'm not even going to talk.
Thought I was older than
I was
that?
going to say younger.
Oh, okay.
I thought.
All right. Well, that's okay. You think I'm younger than I am, that's a good thing. All right. Isn't it funny how when you're your age you want to be older, and when you're my age you want to be younger?
I just want cats. I don't actually want to be younger.
You what?
I just want more cats.
Oh,
I want to be as good as that.
more cats. You're going to be that 80-year-old lady with 100 cats in her house?
Yeah, then when it dies, then you just see on the news 80 cats ate elderly woman.
Okay. So here we're going to solve. We're going to solve this. If we wrote this as a log, you don't have to copy this down, but if I just wrote this as a log, I'd say log base 3 of 32.7 equals 4x. Would I say that?
Yeah.
Oh,
Ready? Say it.
Okay. And if I divide by 4, what do I get?
Probably 1.89.
No, no, it's not the same problem. Good guess though. So let's try it on our calculator. Use your graphing calculator. Now you could demonstrate the base
Point
the
79.
base change again, or you can plug it the way it in the way it is. What'd you get?
Point
0.79. Does everybody agree with that? I thought I heard a different number from you guys. Okay. 0.79. So we agree with that. Okay? If I had used a change of base formula on this, I would have gotten log 32.7 divide log 3 divided by 4. In other words, times 1/4. So I would have gotten this. Okay? I would have gotten that. So there's one way to solve that. Okay? Another way to solve that is to say, if I just take the log of both sides, okay? And most of us will probably remember this method better than we will the other one. All right? So traditionally, this is the way I would solve this myself. And I know the rules really well, and I probably still would have done this. I'm just going to log both sides. And then remember the rule? How can we rewrite it with an exponent, not as an exponent? Move it out front. So 4x log 3 equals log 32.7. And if this is 4 times x times log 3, and I want the x by itself, can I divide both sides by 4 log 3? I'm just using a common log base 10. I intentionally chose base 10 because that's what even this simple-minded calculator knows. We don't need our graphing calculator to solve this. All right? Now here's the problem. We could all plug this in their calculator. We may not all get the same answer. So let's do that right now. I'll pause while you do that. And I want to know that we get the same answer. Okay? So again, to repeat what I just said without the recorder going, you have to either put this in parentheses or make sure you start out with your calculator with a fraction so that the 4 and the log 3 both end up in the denominator. Because that'll give us the wrong answer if we don't. Did we get 0.79? Okay. So there's 2 different ways of doing that one problem. Did I go too quick on either of them? This one applied the rule that we learned to begin with that says log base b of x equals y, then y, then, let me try it again, my bad. Then b to the y is equal to x. That's the rule. We took this problem and went this way with it. And that's how we got this statement right here. Okay? But if we forget that, then you can just take, when the unknown's in the exponent, you can just take the common log of both sides and solve from there. Okay? Yeah? To where? Right there?
Is there supposed to be a log in front of you?
No. No, we learned that on the page where you did all that
Right, but
discover. Just a minute, I'll get to it.
The rule is the law.
Then I told you that this might be written differently in the book than it was written on our paper. And to be honest, I think this is the way it matches up with the book. And in our discovery paper, we ended up with b to the x equals y. So that meant I had the y here and the x over there in their discovery. And I pointed out to you that day that it might be the opposite way in the book, but they just started with different information. But anyway, those are equivalent statements. And this is log form, and this is exponential form. So there'll be no logs in our exponent, in our exponential form, and there will definitely be one log in the logarithmic form. Okay? All right. Anybody not done with this? Anybody need more explanation on this? Okay. Here's another one, solved by graphing. I opened this up this morning. I have no idea what that. I guess it looks like a calculator. At first I thought it looked like a door. And I didn't know what kind of language I was writing in. I must have been a prophet for a moment. Either that or I was very religious and I was speaking in tongues. I don't know what I have there, but
Probably like
I think I'm just now I think it's just a picture of a calculator saying solve by graphing on your calculator. Okay? So what's y1 going to be? What's y1 going to equal? Solve by graphing. Come on, we did a whole paper on this where half of you did the graphing one way, half you did the graphing the other way. A long time ago. Now, we didn't have logs, but it's the same concept. How do you solve by graphing? We have 5 to the 3x equals 103.6. So what do we do? Come on, you gotta show me your care, otherwise I just get annoyed with you and have you move on without me. What's that? y1 equals 103.6? Okay,
Is that right?
that's fine. What's y2 equal? Say that again. 5 to the 3x. So when I graph these on my calculator, what do I get?
Do I have to put it in the table and then I need to do a quick graph?
We have to put it in the table? I don't think we have to put it in the table. So here I forgot to record, so we're kind of jumping in the middle. We have our two graphs. The blue line is actually y equals 103.6, the calculator rounded off. The red curve, which is looks like it's on the y and x axis, is the equation 5 equals 3 to the x. So I go to menu. So you guys missed it if I went too quick. You got another chance here. I go to menu, then I go to analyze, and we want to look for the intersection, so that's number 4. It's asking me for the lower bound, so I have to be on the left side of the intersection. And now it asks me for the upper bound, so I move to the right side of the intersection. When I do that, it gives me automatically the intersection, which is 0.961, comma 103.6. And so 0.961 is my solution. So x is equal to 0.961. Okay? So that's if we did it by graphing. We just did an example a moment ago not graphing, so I'd like you to take a minute and do the same problem here. 5 to the 3x equals 103.6, and solve that by a non-graphing method. So one of the other two methods. I'll pause while you do that for a few minutes. So if we use the other method, I didn't ask you, Abby, how your group did. Which method did you prefer? The first one where we just rewrite it in log form, or the second one where we took the log of both sides and that's how we got the log in the problem? You like this one better? Okay? And so you wrote this as what? First step, nice and slow for me, is old.
I wrote 3x log 5.
So, okay. Can I write it this way first? Equals what? Okay? And then Abby actually went to this next step already. She knew she was writing it this way because she was going to move that exponent out front. And so she went right to this line. And so did Maddie, as I looked over her shoulder here. The problem is when I undo this, I want the x to stay here. So when I divide, I want to divide by everything else. 3 times x times log 5. So to undo times, I'm going to divide by 3 and the log 5. So both sides by 3 and log 5. Okay? So then this cancels and this cancels, and I'm left with an x equals. And then on my calculator, again, I either have to make sure I use a fraction key, or I have to use parentheses to make sure that this 3 and the log 5 end up in the denominator. And so what do we get? 0.961. Same thing we got here, wasn't it? Okay? So I've shown you 3 methods to solve exponential equations.
I like
Okay. What's that? Okay. Now we have a logarithmic equation we want to solve. Too much. This is the last example.
Dang, slow down.
The logarithmic equation we want to solve for x. That 2x minus 2 is all in parentheses because it's all part of this log function. You cannot just start grabbing these things and pulling them out of here. It just doesn't work that way. Okay? So you can't just start grabbing parts of it and pull it out. So, any idea how I could do this?
You put it in the calculator and don't put it
No.
Can
I
you
thought it
distribute the
was
log?
hard.
I can't distribute the log. Nope, that's log of this number, and this number is the expression 2x minus 2.
Nope, can't put it in your
Okay.
calculator.
Remember, I can't pluck out individually those 2's out of the middle of this function.
Divide. I was just gonna say divide the parentheses or get the x by itself.
No, can't do that.
You put the water in there.
Think about how we solved when it's exponential. What are you saying, Aslan?
Solve this
I can't though. I don't have an equation here. I just have an expression.
one. Do we do the whole log to 2x?
No, can't distribute the log.
Oh, you already said that. Never mind.
Yeah, that's okay.
Um,
Hey, I like the suggestions. At least you're thinking about it. No, let's think back to what we did with the other problem. It was in what form? The other 3 problems we did. They were in exponential form. What do we do to them to solve?
add by.
We put them in log form to solve, right? So this one's in log form. What do you think we might do?
Put it in exponential.
Put it in exponential. What's the base of this log? 10. There's nothing there, right? So it's understood to be a 10. So this is really 10. And so 10 to the 4, remember 10 to this power is going to equal this number. Okay? So if it's in log form, you take the base to this power equals this number. So in this case, 10 to the 4th equals 2x minus 2. Well, what is 10 to the 4th? 10,000. Might be big and ugly, but it's not hard to solve, is it? What do? Add 2 to both sides. 10,002 equals 2x. Then what do? So 5,001 equals x. Pretty simple. Okay? That's pretty simple. That's why I only gave you one. Oh, I'm sorry. I was going to say I only gave you one example, but you'll see why I have a second one here. It's a lot more involved than that last one, right? Because I have 2 logs here, don't I? Notice they're both to the same base. I wrote the 10 in, but the 10's really not necessary. Common. Yeah, it would be the base, but it's common logs. So automatically, I just want you to realize it's a base 10. So how can I rewrite this first one? Log to the log. Log x to the 3rd minus log 3. I'm sorry, 2. So then, how do I rewrite it now? What rule did we learn yesterday to help us with this one? Yeah, subtracting logs is the same as taking the log of the quotient. X cubed over 2 equals 5. All right, now what is, I lied, I said it'd be 10 minutes and it's been almost 20. No, not for my time, Mr. What's the base on this log? 10. So now it's just like that last problem. So 10 to the 5th equals x cubed over 2. 10 to the 5th is what number? 100,000. Then what do I do to get rid of the 2? Okay, so I get 200,000. Now what do I do to get rid of the cube? What? Cube root it. I don't think 200,000 is a perfect cube, is it? I would want that. What is it? So 58.5? About? They might tell you where to round. They might say round to the 100th or 1,000th or 10,000th or 10th. If they tell you where to round to and you don't round properly that place, I take a point off. Okay? Any questions on that one? All right, let me